Welcome to the video for Chapter 12, Solid. This one is talking about prisms and cylinders. How do we find surface area and volume of prisms and cylinders? Jumping right into the vocabulary here, the lateral area is the sum of the area of its lateral faces, and the surface area is the sum of the areas of all of the surfaces. So you're just going to add all the areas together. Let's take a closer look at where the lateral area can be found on a three-dimensional solid. On this prism, this is a hexagonal prism because the bases, the top and bottom, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. The top and bottom are hexagons, so this is called a hexagonal prism. The lateral area refers to the area of these rectangles. There are 6 of them. It's a little hard to color in, but here's one on the left. This would be one on the front. And then here's one on the right, and then there are those same 3 on the back. So back left, back center, and back right. So there are 3 rectangles in front, 3 rectangles in the back, so 6 rectangles. And the area of each of those, or the area of those all together, would be considered the lateral area. The surface area altogether would be those 6 rectangles, the top hexagon, and the bottom hexagon. It's the entire surface area. The net down here is a 2-dimensional pattern that folds to form a solid. This isn't such an important vocab term other than the fact that sometimes it is used to discuss surface area, and it's really about how a solid can be created from a flat figure. So I'm not going to focus too much on it, but you can just write it down. But it is a 2-dimensional pattern that folds to form a solid. The other formula we're going to be talking about today is volume. So the volume measures the space contained within a solid. The units are cubed, which is to the 3rd power. We haven't talked about units in surface area because the surface area is just area, so it stays as units squared. But the volume becomes 3-dimensional because we're talking about the area, and then that area of the base gets multiplied by the height, so it ends up being multiplied by this 3rd dimension. So that's why it ends up being the 3rd power. So our units are called cubed, but you could also say the power of 3. So we're going to be looking at surface area and volume specifically for prisms and cylinders. So let's go ahead and take a look at the surface area for prisms and cylinders. Surface area is going to equal the perimeter of the base times the height of the prism plus twice the area of the base. This is the formula I want to focus on right here, this part of the formula, because this capital B, first of all, it is a new letter, capital B for our formulas. It's the area of the base, and this is going to change depending on what the shape of the base is. If it's a triangle, then it would be 1/2 base times height. If it's a rectangle, then it's base times height. If it's a regular hexagon or a pentagon or octagon, then it's 1/2 times the apothem times the perimeter, formula we were using in a previous chapter. Okay, so this will change for every single one. What's interesting about the formulas then is that this formula is actually the same for cylinders, but instead of using perimeter, it's circumference. 2 pi r, that's the circumference, times the height of the cylinder, and then twice the area of the base. Well, the base is a circle, and that's pi r squared, so twice the area of the circle. So these formulas really are exactly the same thing. This one is just specifically in circle mode, putting in 2 pi r for the perimeter or circumference and pi r squared for the area. Before moving on to volume, I would like to point out that this first term in the formulas, this perimeter of the base times the height of the prism, and this 2 pi r h of the cylinder, those 2 pieces represent the lateral area. The twice the area of the base, this is adding the top and bottom, this is adding the top and bottom circle. So just this part of each of those formulas represents just finding the lateral area if you are ever asked just to find the lateral area of a prism or a cylinder. Moving on to volume, volume formulas are pretty basic. It's the area of the base times the height of the prism. So again, finding the area of the bottom and then making it 3-dimensional. And again, moving it into cylinders, the area of the base, well, that's a circle. So pi r squared is the formula for area of a circle, again, being multiplied by the height of the cylinder. Okay, so I'm going to go ahead and go through and explain some of these verbally with the recording, but the rest of them, at some point, we're just going to suggest that you pause the video, do the practice on your own, and then double check your answers. So the only thing I'm going to say about this particular practice problem is that for the surface area part of it, because you are asked to find the surface area and volume, is that remember that the surface area needs the perimeter of the base, and the base in this case is going to be the triangle. I have a length of 4 on one side of the triangle, a length of 3 on one side of the triangle, but I don't know the third side of that triangle. But if you notice, it is a right triangle, and the side we are missing is actually the hypotenuse. So we need to do some quick math using the Pythagorean theorem to figure out what that third side is, and luckily it's a pretty easy one, and that's c equals 5. So my suggestion and what you'll see in my work here is that I'll go through and figure out P, H, and B, and then that way, because those are the 3 variables that I need to find the surface area, and then I'll have the work that goes along with it. So the perimeter would be 3 plus 4 plus 5, which equals 12. The H is the height of the prism, so that's going to be 13. And the area of the base is 1/2 base times height of just this triangle. Notice I don't use the 5 because the 5 is the hypotenuse of the right triangle, and what I really want to be looking at in a right triangle is the base and height using those legs. So base and height of that right triangle is the 3 and the 4, so that area is going to be 6. And so that allows me then for my surface area to be 12 times 13 plus 2 times 6. If you plug that into your calculator, it is 168 square inches for the surface area. And I'm just going to move straight into volume here, because volume is just the area of the base times the height, and we've already found those things. The the area of the base is 6. The height of the prism, the height of the prism is 13. So we're just doing 6 times 13 to get 78 inches cubed. So the work gets done once, but because there's some repetition in the formulas, you don't have a lot to do other than just plugging it in. So at this point, I would get to this part of each of the next couple problems and just pause the video, see if you can work it out on your own, and then double check your work with what I have done already. So this concludes the video about prisms and cylinders, specifically finding surface area and volume. So how do we find the surface area and volume of prisms and cylinders? You use the area of the base and either multiply by the height for volume or add to the areas of the other faces to find the surface area. Thanks for watching.